Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have, as always, a great webinar on tap today, but before we get started, we have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will be able to access the webinar on demand. Following today's presentation, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, just use your GoToWebinar control panel and submit your question. And we'll take probably about 10 minutes or so near the end of the presentation and go through those questions. All right, with that, we'll jump right on into today's webinar, which is Continuous Compliance and DevSecOps in Times of GDPR, HIPAA, and SOX. Our speakers today, as you can see, are Torsten Volk, who is an analyst at Enterprise Management Associates, or EMA, and Anders Wallgren, who is CTO at Electric Cloud. Welcome, gentlemen. Thanks for joining me today.
Hi, good morning.
Thank you.
All right, great. Well, Torsten, I know you are going to be speaking, so I'll put myself on mute and let you get to it.
Yeah, I'm burning to jump right in. And as the opening slide, I created something just for a little bit enjoyment and for Anders to comment on in terms of how important it really is to bake in security into the DevOps pipeline. And we can see an interesting chart about the biggest breaches. This shows how many accounts were breached in the various incidents last year and a few years ago as well. And when you, for example, look at Equifax, they had 15 million accounts of United Kingdom, UK residents breached, and that would have qualified in quotes them for the maximum GDPR penalty of 4% of global annual revenue, translating into about $136 million, which is a nice chunk of change, but it's also a huge blow to the reputation, which was taken anyway by basically all of those vendors. So while a lot of the people on the call are not going to be as large necessarily as the guys that are listed on this Hall of Shame type of thing here, it affects everybody in almost the same way. And Anders, the reason why I say this is this quote down there that I saw in one of the articles where it said the cost of keeping up with changes in technology are prohibitive for basically continuously ensuring security. But that shows a paradigm that really does not work anymore today, right? That paradigm of tying security to technology change in a time where technology changes every day, Anders, right? And that's the crux of the issue.
Yeah, I mean, I think the only thing worse than the cost of keeping up with changes in technology is the cost of not keeping up with changes in technology. I think one of the things that we see, on a regular basis is the fact that companies are unable to retire technologies, right? We don't go off and rebuild an application that's working. Maybe it's a monolithic application, but it's running and it's providing value to our customers and revenues and all those sorts of things. But we don't go rebuild it just for fun because we want it to run as a microservice-based container hyperscale application. So every year or every month or every week, we're adding new technologies to the stack that we need to understand and manage and secure, and that's difficult and it is expensive. There's absolutely no quibble with that.
Yeah, and by definition, if you chase technologies, you are always on the defense. It's always an uphill battle. And I pasted this GDPR Article 25 on this slide, and most of it is cut off, but it is a very good reminder that data protection by design and securing DevOps pipelines by design is the only way to go. And what by design means is it is taking security, compliance, the operators out of that critical path where you can release as frequently as you like, but you are only to a small degree, to an insignificant degree, increasing the workload on the developers, on the ops team, on the security guys, and basically the cost of each release is minimal from the cost overhead is minimal. So Anders, we did a research report, and we do a lot of research reports like that. This one was on containers. We've just done one on serverless, but they all come to the same conclusion: security and compliance is the number one pain point, is the number one thing that lets the guys who are in charge, the guys with a business responsibility, not sleep at night, keeps them awake at night, because they're just wondering if they are on top of things. Is that something that surprises you, considering the current situation?
No, and I think in some sense, it's always been that way, right? Because security is not something that you can see and touch. The way an actual feature in your product that customers are going to use, right? So security, in some sense, is the absence of lack of security, which is, I know, a goofy thing to say, but it is one of those things where you can't just sprinkle it on at the end as if you were in a restaurant and you're finishing a dish right before it goes to the table.
Right.
And we've done that with performance, we've done that with security, we've done that with quality, and I think by this time, I think we can claim, fairly robustly that approach does not work. That security, quality, all of the performance, all of these things need to be baked in from the beginning. They need to be treated as features of the product, not afterthoughts, or not runtime or deployment or operational issues. Security certainly is an operational issue. Don't get me wrong. And things need to be monitored and all of those things once they're in production. But you can't just add security on in the last week before you release the product, right? It has to be baked in from the beginning.
Yeah. And that really takes us to what we currently see in enterprises. And the phenomenon is that DevOps is not a new thing, right? It's not a recent trend. It's been around for quite a while, but we still see a lot of variance in terms of how individual teams, even within the same organization, implement their DevOps pipeline. And that's not limited to having different tools, because that's totally fine. You can't limit the developers to a certain set of tools, and they will use that as a reason for why they can't be as productive as they normally are. But it's much more about the process and the metrics and the culture overall that is different between DevOps groups. And when you talk of metrics, that's a very big point, that most organizations, they do not exactly know how to prove if something is going well, if something is going badly. And if you can't prove it, if you can't look at the metrics, and we'll show some of those metrics later, then you can also not replicate your success, and you cannot prevent your failure and drill into why these metrics are looking good or bad, and learn from that for the other teams. And the interesting point here is the time pressure. We always want features right now, and we don't want to be the ones who hold up the release. Developers don't want to be the ones that hold up the release, and neither do operators. So we do things that we shouldn't be doing when time pressure is there, when we know we need to ship software so that customers can use that software. And those are often subtle things that developers make their own judgments, and they think, yeah, it's probably fine like that. It's not too bad what I've just done. I don't think I have to escalate this. I'll just squeeze it in and I'll fix it next time, and then it never gets fixed. And there is a nice hole in the overall security. And Anders, what makes this situation even more interesting is you see every cloud speaks their own language. AWS, Azure, Google, Cloudflare. I mean, there's lots of others. They all have their own language. Like AWS has CloudFormation, and Azure has the Azure Resource Manager. They all have their own definitions of services, and to control that centrally, the configurations, the deployment processes, and how everything is set up, that is even more difficult, especially when you see that almost 50%, almost half of enterprises are using all those three hyperscale clouds, and a lot of them have more than just one account. Often we see dozens or maybe even hundreds of AWS or Azure accounts within the same organization, all set up slightly differently.
Yeah, I mean, it is a challenge, and I think, in some ways the fact that there are multiple cloud vendors being used by many organizations out there, if not most, quite frankly. I mean, that in some sense just reflects the way that things work in the real world, which is, in a 50,000 or 100,000 person company, or even in a 1,000 person company, you don't necessarily know what the person down the hall or down the road or across the world is doing, and they may be deciding, hey, AWS is what works for us for our particular product, and then somebody else on the other side of the world says, well, no, actually, this Azure thing is pretty cool, and we want to do that, or you've got mergers and acquisitions and those kinds of things. So sometimes you inherit technology stacks from that, and that certainly hasn't changed, right? I mean, if you're a Java shop and you acquire a product written in Python, you're now a Java and Python shop. And it's incumbent on you to do well with both technologies, and it's the same with cloud technologies. There's really, it's a difference in degree maybe, but not a difference in kind from the kinds of technology challenges that we've always had. So in that sense, it's just sort of more of the same, I would say, in many ways.
Yeah, and when we look to topics, there are bread and butter security topics like managing keys, consistently encrypting data, setting up role-based access controls. If you do that on an individual basis, not only do the individual clouds have different capabilities and different ways to manage keys and encryption and RBAC, but it's also, if you have different groups, even between the same cloud, there are so many parameters. If you don't centrally manage them, you can't report on them, you can't make an emergency change, you won't even know exactly if you're vulnerable to a certain kind of attack, because you may not know across the company that it's an issue, that you're using this setting, and that's a big problem, which leads us to the what we called DSL overkill, domain-specific languages, so basically YAML languages. Anders, do developers like YAML? Are they enthusiastic around coding infrastructure in YAML? Are they thorough? Do they burn on spending their time on YAML?
I think DSL for me is a favorite subject, because we make a lot of use of DSL in Electric Flow, our release orchestration software, and so I'm a big believer in declarative languages. I think there's definitely a huge amount of positives around that. In terms of things are declarative. If you make changes to them, you now have something that you can diff, and that's pretty important, right? Because if I can show you on the left side is what we used to do, and on the right side is what we do now, and then it's very clear, what the difference is, that's a lot easier than kind of pointing at a web page and saying, see how there's 4 boxes there and now there's 5.
Yep.
So I think from an audit and governability, and also from a testing point of view, right? Because you can test that DSL, right? You may not even need to execute it. You can introspect on it and say, we require that we do X, Y, and Z, or we require that we not have this type of element in here. You can run tests on that are much easier to construct and to run. And again, not that doesn't solve the entire security problem, obviously, but that gets you pretty far. And so, I'm a huge fan of DSLs. We certainly in Electric Flow, we make great use of that, as I'll show a little bit later. But I think the problem is, as it is with all technology stacks, is you need to know what you're doing. You need to understand what it is that you're doing, and quite frankly, a lot of times people don't. Right? There is definitely, and anytime there's text files involved, whether they be YAML or Groovy or make files or POM files, or I don't think anybody really enjoys typing those things from scratch. So I have an obscure theory of mine, which is there was ever only one makefile written from scratch in the world, and every single makefile has been copy pasted from there. Sort of the Adam and Eve theory of makefiles. And I think that applies equally to DSLs and YAML files and POM files and all of that stuff. So I'm not picking on Make in any sense of the word. But you know, you have to understand what you're doing, and if you're copy pasting your way into things and not really understanding the content that you're modifying and why you're modifying it, how what you're doing is important, you know, from a security perspective, then you're not, you know, then there better be somebody down the line who does, or you're going to have problems.
That we see all of those languages. You see, I just pasted a couple of nice examples here that show each one of them is, the whole idea is that they are human readable. So each one of them is human readable pretty easily, but
by some definition of human, yes.
Well, okay. That shows maybe how far we've come. But what you need is a centralized way of managing parameters, because you know, between Azure and AWS and then Terraform and Chef that are all used in the same enterprise, that there's a whole big mess in terms of server parameters. How do you set it up? How do you set up SSH? How do you handle certificates? How do you check for expirations of certificates? I mean, there's a whole bunch of critical issues that if you overlook one and you update all the others, then somebody can penetrate that one issue and exploit it and you know, turn your worker servers against the management nodes, or, you know, do whatever bad things they could be doing.
Yeah, I mean, you know, it's interesting that you mentioned, you know, managing certificates and keys, because that is, if you go read the GAO report, the Government Accountability Office report on the Equifax breach, one of the reasons why the breach was so serious was that Equifax were not able to introspect network traffic that was encrypted on their own network, because the certificates on that product that they were using were out of date. And that's one of the reasons why the bad actors had so much time on their hands to you know, to egress the data, you know, slowly over a period of time, and they were not detected. And
that's a good point, because you can make a bad decision consciously. You can make, as a business person, the decision of putting the release date over the certificate update, over the security. But then, you know, you have to, you know, it's your neck on the line for that. Versus if you didn't know it, right? If as a business person you thought they had done all this, but then it turns out they haven't.
Yeah, and you know, it's kind of a philosophical question of which is worse. You know, the kind of the neglectful approach, or the, you know, the kind of we're going to take a risk approach. You know, I think you could argue, I could certainly argue both sides of that question. But I think it's, you know, a lot of it is dotting the I's and crossing the T's and being detail oriented and making sure that, you know, things that can be automated are. You know, computers have a lot of faults, but one thing they don't generally do is forget things or don't do things, you know, when we request them to do it. Whereas, you know, with humans, we're much more fallible, quite frankly, and much more, you know, liable to forget things or be delayed or those kinds of things. So, you know, automation is our friend for these kinds of things. That's for sure. It's not going to solve the entire problem, clearly, but for things like, hey, are the certificates in our critical, you know, network monitoring technology out of date, so that we're not actually introspecting on, you know, encrypted data that moves across our network? That's probably something that you want to automate, at least, you know, checking, you know, if not just updating altogether. So, you know, we all have to do better. That is a clear answer there.
Okay, so I don't want to get stuck on this slide too much, even though we could talk about it for another hour. There's an interesting article on the Kubernetes IO website, 11 ways to get hacked, to get your Kubernetes hacked. And I pasted only 4 of them here, but this is more than enough for everybody to get the idea, because I said the other day on a panel or in a presentation that Kubernetes is introducing a lot of security vulnerabilities, right? And I said that out of kind of a resignation of looking at deployments and seeing that they're only 90% hardened, and that they are they're different in the same organization. Kubernetes is set up entirely differently, configured differently, behaves differently, secured differently, and there's no central way of reporting on this and of enforcing best practices there. So you can have done your policies, bottom left, perfectly for the network. You can have secured your role-based access, you controlled your logs, encrypted most of the connections, but then forgot encryption for one connection type between services and nodes, and that one thing, that one oversight that you forgot on this one Kubernetes instance that somebody may have set up for staging the training software for machine learning, or for any good reason, right? There's always good reasons why we set up another Kubernetes instance, and they're not fully hardened, and then we bring them forward in the DevOps pipeline, and all of a sudden something that's not fully hardened ends up in production. And again, we have no way of centrally reporting on it. We don't even see that there's an issue, and it's only a small issue, so somebody exploits it, and nobody ever notices until a few years later somebody sees, wow, they've been abusing our data for multiple years. What are we going to do now, right? Anders, and those are the interesting ethical dilemmas that you are in when you are
I think the thing here is, the security is a chain, and if you have a single weak link in the chain breaks. So you can get 10 of these 11 things right, and if you miss the 11th, you're hosed. And as we were kind of discussing a little bit before we started today, but if you've been reading the news in the last 24 hours, there's a vulnerability was just disclosed in RunC, which is one of the main processes involved in running containers, that allows you to break out of the container and into the host operating system, if I read things correctly. So maybe there's 12 ways that you need to secure your Kubernetes installation now, rather than 11.
Yeah, because we were talking to people who were concerned. Could it ever be, because it's a shared kernel, that you can hijack the host operating system? And we always said, no, that's it's isolated. That's the whole crux of it. And now we can see it happen.
Well, everything can happen when there are bugs, right? Bugs are these kind of non-linear things that when they're present, they violate the principles by which we try to operate and run and design these things. So, a bug is a bug. It's already, as far as I know, it's already been fixed. And the question now is, will operators of containers that utilize RunC, will they patch, right? And as we've seen, and I don't want to beat Equifax into a bloody pulp any more than I already have and everybody else has, but that was one of the issues, right? Is how long does it take you to roll out patches for security critical incidents, and do you even know that you need to?
Yeah, and that's what we see. It's usually the ones that were already known that they were there, but you were worried that the application may no longer run if you patch it, right? We've seen this OpenStack plenty of times where people were 3, 4, 5 versions behind, and the same thing is the case with Kubernetes. Do I want to jeopardize operational stability, or do I want to?
And I think this is where DevOps, and particularly kind of the flavor of DevOps that we refer to as DevSecOps, comes in, because if you have a properly constructed software delivery pipeline, which is essentially your supply chain for your software, then doing updates to these kinds of things are far less disruptive than they are when everything is kind of done ad hoc and manually and those kinds of things, because you have the ability to run through your entire pipeline with the orchestration that something like Electric Flow provides, and make sure that everything does work before you flip the switch and do the deployment into staging and production and the higher environments. And so anything that is part of the runtime of a product, that's part of the operational aspects of a product, have to be quickly patchable and maintainable. There is no excuse, or soon there will be no excuse, if there even is one today, for not being able to rapidly update our environments in response to the kind of critical incidents like the RunC vulnerability disclosed in the last few day or two. So it's equally important to have, as equally important as having kind of security built in and quality and all of those kinds of things, is the ability to have a flexible software delivery pipeline that allows you to very easily say, oh, here's a new scan that we need to run, or here's a new test that we need to run, and have the ability to very quickly put those into place.
Anders, here's the excuse. This slide shows the excuse that, and it's pretty legitimate, right? There's 11 different examples of how you can architect Kubernetes, and there's another 50 probably out there. So if you already have all of this stuff here in place, then it's gonna be harder, right? Because they will respond differently to patches and to hardening actions and to all kinds of things, right? And it will be hard for you to control those separately unless you abstract the technology away from the policy and the pipeline automation. But every time I, as an analyst, use the word abstract away, people start, their eyes starts glazing over, and they think, oh yeah, he's living out there in the land of theory, right? But that has a very good reason, because if nobody wants to be restricted in terms of which Kubernetes deployment they're using, right? Nobody wants to be told, oh no, you can't use OpenShift, you can't use Docker, you can use whatever you want to use for this project, because that helps you get it done. But if it's then tied to the technology, you have a problem and you want to fix the security issue.
Yeah, I mean, you have to manage the technology that you use responsibly, and part of that, I would argue, implies that you understand the technology that you're using. You understand, what does it take to update it? What does it take to deploy a new version of our code on top of it? What does it take to deploy a new version of it itself? And do you have people whose job it is to wake up every morning and make sure that that there aren't any emergency patches that need to be applied to keep things secure? And quite frankly, that's just part of the job, right? I mean, that is part of your responsibility when you accept my private information and use it. I'm getting a good, I'm getting a service out of it. So there's definitely an exchange of value there, which is why these our businesses are so pervasively are all about software these days. Basically, it's eating the world, as the man said. But there's a responsibility to understand these things, and if pick any one of these, right, and it's going to have pluses and minuses, and you better understand those. And maybe you don't pick the right one out of the gate. Hopefully, if you decide to switch horses midstream, you do so before you go to production. And then you stick with that for a while. But the maintainability and updatability and so on of any of these approaches, whether it be Kubernetes or containers or VMs or static instances or what have you, you still have to maintain it. You still have to patch it. You're still responsible for that. And I think understanding that and knowing that just because you put it into production doesn't mean that you're done. Right. And in some ways, that's when the real fun begins from a security perspective, because now, people can walk up to your front door and check to see if it's locked or not. And that definitely is something you got to keep in mind.
It redeems the operators and the DevOps engineers quite a bit here, because they now have the role of taking the technology out of the critical path and taking themselves out of the critical path. So they're going from this reactive role to a proactive role, where they make their systems and the systems throughout the enterprise scalable, and that just costs man hours, right? It costs planning, it costs people keeping those systems running that make sure that you are in the position of addressing issues at any point in time. Versus, I remember a couple years back, this was a major system software vendor on stage. The CEO was talking about how developers will now manage all of the IT infrastructure. They will manage their own container infrastructure, and nobody will have to worry about infrastructure anymore as a whole. And that created this big problem of everybody doing their own thing, and all of a sudden we had all those holes in the Kubernetes deployments and setups. Even though Kubernetes is very secure and Kubernetes is great for policy-driven application placement, it's perfect. It was made for that. But if you change your philosophy from the old ways of doing things, an infrastructure-centric way, to now an application-centric way, where all of a sudden the infrastructure guys are not fully in the saddle anymore, they don't fully understand it anymore, then somebody else has, or the infrastructure guys have to be upgraded to a position where they can be responsible again for performance and security and availability and all of those admin issues, all of the boring overhead issues.
Yeah, and I think it's not that I don't think you meant to put it this way, but I don't think it's ever actually been true that it's, it's only the operators, it's only the ops people that are responsible for the security of applications, right? In reality, developers, QA people, product managers, product owners, I mean, we're all responsible for the security of applications. And unless we take that seriously in all of our jobs, then we see what happens. Whether there could be a coding error that leaves a vulnerability in, and it doesn't matter how well you operate that product as an ops person. If there's a vulnerability or a backdoor in it, there's nothing you can do about it. Flip side, no matter how secure my code is, if it gets run in an unsecure environment or an unstable environment, doesn't matter how good the code is, it's gonna get hacked. So it's everybody. Quality is everybody's responsibility. Security is everybody's responsibility. It's a little bit dangerous to say that, right? Because saying that it's everybody's responsibility in some sense dilutes the responsibility. But at the same time, we can't just say that, oh, we're going to have one throat to choke about security and it's going to be the ops guys, right? That doesn't make any sense either.
Right. Security has to be embedded in the overall process. And when you look at the different flavors of serverless, I call it the slide, and I produced this, and I did it in my own PowerPoint, so it's not looking all that nice, but it got a lot of resonance in terms of people saying, wow, I thought the whole idea about serverless is that it doesn't have a stack. But serverless actually does have a stack, and the stack is not even fully represented on these individual slides. The point of this slide here was to show people how different even the deployment principles are for serverless. What you can do here on the left, we have basically SAM, the serverless application model, just put on top of CloudFormation. So it's, if you will, you put one DSL on top of another DSL, and to simplify the serverless use case, but it's still introducing one more layer of complexity. And then we see all of those other vendors who are having, they have their own twist on simplifying the serverless endpoints, right? You can see the conundrum here, serverless endpoints. You're still dealing with API endpoints, and the API gateway routes the serverless request to your server that you are programming, right? The only difference is that the runtime itself is now not under your control anymore, but you can still introduce all kinds of security issues that are specific to, like when you look in the middle, the serverless framework, you see if you use Lambda, you use OpenVis, Kubeless, any of those frameworks for serverless computing, you can introduce little surprises from a compliance and security perspective, depending on how you code. So the developer is very much responsible, but the operator also has to have the reins in some manner, right? And that is what we basically need to find, so that when you check your stuff into GitHub, you check it all in, and it gets all reported on, it gets all controlled centrally as code, right? Instead of being all over the place, and you don't even know what you have in terms of configurations.
Yep. I think that, abstraction, you mentioned abstraction in one of the last couple of slides in terms of, when you start talking about that, people's eyes glaze over. And, and I think that's a shame in some sense if that really does happen, because abstraction is incredibly powerful, right? We would not have computers without abstraction, right? We if we were all, building, stuff out of transistors, nothing would ever happen. And if we were all still building in machine language or in assembly language or any of the lower level constructs, we would never get anything done. So abstraction and modeling built on top of abstractions are incredibly powerful, right? Because, instead of saying that, oh, I need 50, computers and I need them to have these IP addresses and so on, at least I can just say, look, what I want to do with these things once I have them is I want to run this service, this piece of code, and I want to invoke it, roughly this often, and I want it to take roughly this long, and here's the kind of storage I might need for it. And you can have that conversation at a much higher level. And then you really can, kind of abstract away a little bit the notion of, well, securing that infrastructure, by itself, modulo that I don't have any of my code running in it yet, that really does become or can become somebody else's responsibility. And that's a pretty powerful thing if you compare it to, what we did, even, still doing today, obviously, because again, we're not retiring technologies, but standing up an operating system from scratch every time, making sure it gets patched, every single time. But that operating system is also running my, J2EE container and my application, and, can I patch it and reboot, and how, all of these things, right? If you can abstract those things away, and really what you get out of abstraction, which is incredibly powerful, is decoupling, right?
Yeah.
When things go slowly, when security becomes the department of no, is when everything is coupled together, and we can make no decision independently. We all have to make decisions together before any of us can move forward. That's when we get mired in the depths, and that's why we don't upgrade or apply patches for years at a time. Because we can't move anything until we move everything. And so the layers of abstraction allowing us to decouple pieces of the architecture, I think, is incredibly good ultimately for security. But it doesn't in any way absolve us from the running those things properly at each kind of level of the abstraction, if you will.
Yeah, and there's always a buzzword of the day. Yeah, this is a very recent drawing of our EMA serverless stack with a service mesh at the top. And if you ask somebody, ooh, how are you securing your service mesh, right? People will look at you and think, wow, we're just playing only now with service mesh, and we are exploring what it can do and how it can do it. And the same is true for Knative as we call it serverless middleware, where you basically connect the serverless code, your function that you write in Python or JavaScript or C# or any of those languages. You need to connect those to Kubernetes somehow, so that the code runs inside of a container and scales and gets access to its stateful information. And Knative just came up a few months ago, right? 6 months or so ago, out of nowhere from Google. And there's a couple of comparable technologies that all of a sudden try and simplify serverless computing and make it a little bit more low level and a little bit more controllable. But it's just one technology, right? Before, a lot of vendors were saying, yeah, no, we connect straight to Kubernetes, right? OpenWhisk or whatever, Kubeless, all of those serverless technologies, OpenFast, we connect straight to Kubernetes. And it turned out, yeah, that was harder than they thought. So now we have something inside of that stack, and now we also have a new category evolving of tools that orchestrate a service mesh, right? Service mesh, the category hasn't even fully matured and taken off yet, but there's already abstraction layers for those tools, because people notice that companies use multiple of them, and nobody knows who the winner will be. And so the stack here that you see in a year could look entirely different. And then if you have your solutions coupled to one of the individual layers, you're already living in the past. And that is the problem, that this declarative approach, this tech independent approach never really broke through. And that's what comes back to bite all those vendors on the first slide, right? And I mean, that's what you regret later if you hack it together in spaghetti code really quickly now.
Yeah, and I mean, at the same time, it's the reality is this is a competitive marketplace, and people are always going to be looking for either wanting to provide or sell the next greatest new mousetrap. And that's part of how technology evolves and improves, so that part of it is healthy. Now that means that, when there is a new kind of, I'm going to use the word breakthrough, which I don't know if that's appropriate. When there's a new breakthrough technology like containerization, for example, there is going to be a lot of froth around that. But it eventually, I think, does settle out, and the real players emerge, and the ones that are responsive to their customers and responsive to the needs, and provide timely updates and patches and all of those things are the ones that that's part of what it takes to become a winner in the marketplace. And I would argue that system works. I think that's kind of time tested, even though we have lots and lots of vulnerabilities still, and lots of breaches. And I mean, bank vaults are not perfect either. They can be breached. People are still digging tunnels into banks. I mean, there was just just a couple of stories in the last couple of weeks on how people were trying to tunnel into banks to as Willie Sutton said, where the money is, that's why I go there. And that's going to be the case, forever. I mean, this is an arms race, right? It is the good guys versus the bad guys, if you will, and that is always going to be the case. There's always, if I have something of value, there's always going to be people in the world, and maybe I'm just a cynic here, but there's always going to be people in the world that are going to want to take it and not earn it.
Yeah.
And that's the reality of living in the world, and we just the more we acknowledge that and take the appropriate steps, the better off we'll be, quite frankly. So.
Yeah, and the challenge is that this transition to the metrics you can see on this slide is somewhat independent from your day-to-day defense against all of those threats, all of those guys tunneling into your Kubernetes managers or your vSphere servers or your bare metal. It is you have to keep those at bay while transitioning into this state of automation and of abstraction, and that adds obviously an extra challenge. The legacy hairball that never goes away of technologies that you always have to continuously support is the problem here. And we put a couple of metrics here on the slide that show or that enable enterprises to see where they are on that journey from a reactive technology-centric approach to a technology-independent, proactive, and automated approach where security is built into the pipeline. And those metrics, nobody can obviously track them all, but those metrics, when you pick them, there are some very interesting ones. A lot of people in software, I remember myself in that role, get very upset about the repeating occurrence. Where we used to have repeating security issues, but in different teams across the enterprise, and it was always kind of the same root cause, but we found that it was not really ever addressed consistently across the enterprise. So picking some of those factors, that hurt you right now, and starting to institutionalize the measurement of these factors without any excuses, that is a good starting point. And it brings me to the 4 key takeaways on this slide here that are basically the summary of the discussion that we just had. And those all come down to number 4, that accepting exceptions of these rules, that technology and operations and development, they can never be in the critical path and slow down this delivery process. Whenever you make an exception and enable a group to say, oh yeah, we couldn't automate this X by C process for the following reason, we couldn't test automate. We had to do this environment separately from the rest. If you do that and you accept these apologies for what they are, you basically let people get away with that, then your dashboard means nothing, and that's the problem. So it's better to start small with picking only a few of those.
Absolutely, yep.
And and institutionalize them, and then go beyond that. And
when it comes to metrics, less is definitely more. Less is definitely more when it comes to metrics. I'll say that, kind of as a summary there while we swap over our slides here for my stuff. I think. I think it's one of those things where it's definitely the case that technology is both our friend and our enemy, right? Technology is the reason we're having these changes, right? So we absolutely we absolutely need to pay attention to that. We absolutely need to treat that very, very seriously. And kind of go after that. And what I'm going to do, kind of with the remainder of our time here, we'll have Q&A at the end here for sure. But also talk a little bit about how Electric Flow, our release orchestration product, and also Electric Accelerator, our build and test acceleration product, can help and does help our customers in this arena. And if somebody could just please make me presenter so I can drive.
I'm trying to make you presenter. I seem to have it. Maybe not.
Thank you so much.
Okay, did somebody else do it? Okay, good. Yeah, I was just advancing the screen. Okay, go ahead.
Yeah. Okay, so hopefully we can see my slides.
Yes.
Great. So one thing I want to talk about here is kind of the idea of the kind of your software supply chain, if you will. Your path to production in some sense, right? And there are lots of stakeholders involved in this process, right? You've got engineers that are writing code. You've got people that are responsible for building and testing that code and delivering that code, releasing it, running it in production. And there are many things that need to happen for this to work. And one of the most important things in the industry these days that we're talking about is this notion of DevSecOps, right? Which is if we're going to do DevOps, which is many things to many people, but is certainly one of the best ways, I think, to reliably and repeatably build, test, qualify, and release code. It's incumbent on us to identify what we can do in order to better secure the software. So one of the things for sure that you want to do is make sure that as part of your process, you use whatever product, homegrown or commercial or open source. There's a number of them obviously on the slide here, to make sure that you're taking your best effort at making sure that things are secure, that you're not deploying third-party dependencies with known vulnerabilities, that you're testing your deployment artifacts, whether they're containers or WAR files or what have you, and going through that. And that our approach to this is you model and you automate everything, right? Manual steps are sometimes still required. There are still processes that are either manual because they require, this is an approval step, so we need to sit down and have a meeting, which I would still argue we can probably, if we work hard enough, get rid of most of those as well, because we tend to do things like look at spreadsheets there, and computers are pretty good at looking at spreadsheets too. But model and automate everything, and again, that's where we get into the whole idea of the notion of abstraction, as we talked about earlier, right? That we think about our environments and our applications at a little bit of a higher level from the point of view of management and governance. And then we want to monitor and track these releases as they work their way through the pipeline, and give visibility across the enterprise on what's happening with our various releases, and provide transparency and data around that. And I think this third point is very important. I'll go into a little bit of detail on each of these, but provide environment security and automation as a service, as a self-service type of thing, so that if we have a certain way of doing X in a company, we have a certain way of deploying a container, we have a certain way of deploying a WAR file, we have a certain way that we run WebLogic or WebSphere or JBoss or what have you, that you provide that as a self-service type of thing, so that as I like to say, if you're ordering off the menu, you just point to the menu and you get it. You don't have to wait for 6 weeks to get something provisioned. You get it in 15 minutes, and you don't have to stick your fingers into it and mess around with it. You don't have to go check it to make sure it's right. It's being done automatically and off of an approved set of ways that we do things. Very, very important. And that also allows you, and as we kind of alluded to earlier, allows us to adopt new technologies safely. Kind of the key word there being safely, because we adapt them into our release orchestration pipelines, our software delivery pipelines. And if we're doing a new kind of, if we're doing code scanning on WAR files, and that's our primary way of making sure that third-party dependencies, don't have vulnerabilities in it, for example. And all of a sudden we decide that we're going to change tack and we're going to deploy these things as, as fully formed containers. That might change the way that we want to do, security scanning. So we want to make sure that we're able to very easily adopt, any new kind of stages in that pipeline, if you will, where we need to take that into account and really kind of build in the security and compliance from the beginning. So when I'm talking about automating and modeling everything, I'm talking about literally everything. Modeling, the application components, modeling the processes about how we build, test, and deploy and release those applications. And in Electric Flow, you can either do that using our very cool and awesome user interface, or you can also do it using DSL, using domain-specific languages, which hey, sorry to add another one to the world, but we think it's justified and kind of useful. And what you see in the screenshot here is really just a literally representation of the two different ways that you can work with this in Electric Flow. You can be writing code, or you can be using kind of drag and drop UI type things, as we're all familiar with. But the key thing about DSL in this instance being, this gives you an artifact that you can version, that you can check into your source code management system. You can have code reviews, you can write tests against. It becomes a mechanism by which we can have discussions with the audit and governance parts of our organizations in terms of, last time we went through this, you said, hey, are you doing X? And we said, no. Well, here's X, right? And here's how we're testing that X happens every time. Those kinds of things. Very important things to cover.
Well,
and then monitoring.
What if I have Puppet or Chef and I like those?
Keep using them. I mean, side comment is, I'm not sure how relevant Puppet and Chef are going to be in a world of containers, to be honest. But yeah, I mean, keep using them. And there is another DSL, right? But that's another thing that, again, Electric Flow will manage for you. So you can provide a self-service catalog for standing up environments to the spec of your organization. And Electric Flow will talk to AWS to get the AMI set up if that's what happens. Talk to Chef to make sure the right recipes are run, or Puppet or what have you, and so on. So in some sense, Electric Flow, our goal is not to become tool number 501 in your already pretty crowded toolbox of doing these things, but to be something that can govern and help you manage all of the tools that you're using today. And provide a level of abstraction to where we have a tested way that we do X. Whether X is we use AMIs, or we use containers, or we use Chef and Puppet, or what have you. That X is provided as a way that's well known and abstracted away from the people that consume it. In the sense of here's a service that we provide. It's secure. Please use it. And if it comes time to adopt a new technology, we adopt a new technology, but we do so safely. We do that within the within the structure of the best practices that we put into place using tooling like the software pipelines in Electric Flow. But the key then being, now you can start to monitor, right? And you can track the progress of your releases through these pipelines. So just from a pure kind of how do I get stuff out the door approach, this gives you a lot of visibility across the enterprise into what's going on and what people are doing, and gives you with the modeling especially, gives you a way to share best practices and have ways that as you were alluding to before, that we have some consistency across the enterprise, right? Here we have 50 teams that use product X, whether it's a J2EE container or whether it's Apache or what have you. Here is the way that we deploy X. Here is the way that we use X. And that if we fix a hole in the way that we do that the benefit of that accrues to all the organizations across, right? Without huge cost to getting that benefit deployed across the organization. And that's pretty important. And once you start to look at that, you can now start to look at sort of details here. And if you look in the little magnifying glass, I'll just point out, to your attention, example here, obviously, but, kind of in the bottom left there, 99.69% manual, right? So out of the, we had 30 minutes or so of automated tasks, and then we had 12 hours. I assume these are in hours. I can't actually see the units here, but, most of the things we're doing in this pipeline is manual. Well, that better be for a good reason, right? Because otherwise we could go a lot faster, A, and B, we could make sure that we make a lot less mistakes if we automate. If you look at where mistakes are introduced, it's generally during manual handoffs or doing manual tasks. I mean, even Amazon themselves are not immune to this, right? A simple fat fingering, basically brought down S3 for a while. So we're none of us, even the giants among us, are immune to these kinds of things. So automation is our friend, because we know if it did it a certain way last time, it's going to do it a certain way the next time, right? We're not going to forget step number 462 out of the 612 steps that we need to do to securely deploy our application. Computers are generally pretty good at those kinds of things, whatever else their faults may be. And then, again, kind of, providing environments, securely deployed and automated as a self-service for your internal users, so that, again, if you look back a few slides to what Torsten was talking about in terms of here are the, here are 12 out of the 48 different ways that you can deploy a Kubernetes container or deploy a container into Kubernetes. Provide some governance around that, provide some best practices around that, and at the same time, make it very easily accessible to your users, right? One of the first things I learned when I learned about security back in my college days many decades ago was security that isn't usable is not good security, right? Because if you make it difficult for secure ways to kind of be the defaults, people end run it, right? People ignore the rules if it suits them or if they have to, right? Especially if you have an MBO tied to a ship date or something, you're gonna break the rules. That is
your own Kubernetes cluster. You do it yourself, and you do it outside of this.
Yeah, and so I think for a lot of our customers, they get huge amounts of value out of something like the self-service catalog that we provide, where here is the way that company X does a secure deployment of Kubernetes. Now, tomorrow we may decide here's a better way to do that, right? So now we need to go update, but we update it in one place where we do the self-service catalog, and so now the tomorrow when we deploy the next application, it will automatically be picking up the new way of doing things. And again, that's a level of abstraction, right? And levels of abstraction are incredibly powerful and incredibly useful in preventing things like forcing people to dive down into the nitty-gritty details and dot every I and cross every T every single time when they do this. So that is incredibly important.
As long as they're not seen as a burden, right? A lot of people, this declarative paradigm, a lot of developers, a lot of operators, they see it as a burden to get into, and you need to alleviate that burden and make it simple and say, look, you can use OpenShift, you can use native Kubernetes, Docker, anything, but we will take care of a consistent reporting for audits, consistent deployments, consistent everything. As long as you can do and give them that, they have no reason to go around you.
Exactly. I mean, and frequently when people end run the system is because the system isn't serving them well, quite frankly, right? If it takes 2 months to get something approved, and I don't have 2 months, I'm either going to ask for a variance, right? I can't tell you how many times, we hear customers talking about, well, that's usually not the way we like to do it, but, we were under time pressure, so we got a variance. And much better, I think, to provide a system where, with a little bit of effort up front, you now have a secure and governed and auditable way that these new technologies can be applied. Whether it's self-service catalog or kind of using plugins that we provide or that are provided by the community and those kinds of things. It's really critical, I think, that we involve everybody in that process, but not in such a way that everything takes 6 months to get accomplished, right? Because then people will start ignoring the system because it doesn't suit their needs. So,
yeah, Anders, I just see an interesting question maybe to finish things off from the audience here, that goes like, where to start implementing security within large companies with huge IT departments, or with huge IT depths on legacy systems that are moving towards new technologies like multi-cloud. Where do people start? Because they have this huge legacy hairball. They may have 1,000, 1,500, 2,000 applications, every technology under the sun. Where do you recommend they start reining that in and governing that?
I think it's important to be kind of a little bit forward-looking in that sense, and I'll give an example of what I mean by that in another field, which is building codes are improving and changing all the time. Sometimes we make a change to the building codes that's serious enough that we actually require old buildings to be retrofitted, but most of the time not. I mean, we certainly know how to build a skyscraper much more safely than we did, say in the 1960s or earlier. But we don't go tear down the existing buildings, right? That isn't practical. That isn't safe. All sorts of reasons why we do that. Same with applications, right? It may simply not make sense to go figure out how to squeeze an existing application into these new paradigms. It may make more sense to focus on, improving the security of the new technologies that you're adopting that are going in there, and continue to do what you're doing with the existing applications until they get transitioned out and end of life. Although I say that sort of, with a little bit of a raised eyebrow on my head, if you could see me, because you know, the end of lifing applications is difficult and doesn't happen nearly as often as it you know, probably should. But again, you know, we don't go rebuild buildings either. So you know, we accept that as part of the risk profile of doing business, that the technology that we choose may be the technology that it has to run on forever and ever until we retire it, that there is no way to sort of shore up and improve the underpinnings of that, and that we just have to make sure that the next one we do is better, right? And you know, that may be a hard pill to swallow, but that is reality. You know, that is reality.
Anders, I think we have to wrap this up. We are within a minute of our full hour.
So what I'm gonna do, I'm gonna skip past here and I'm gonna put up just our Electric Flow Community Edition here, and just kind of pitch that people go take a look at the product. You know, we didn't get a chance to look into it too much in depth here because, you know, we had interesting content to talk about. So I'm not sad about that at all. But we'll toss it over and see if maybe we have time for a question or two. I know we've hit the top of the hour, but maybe we can squeeze one in.
Unfortunately, we don't have time for any questions. We are at a hard stop at 2 o'clock Eastern, but I do want to thank the audience for joining me, and I do want to thank Anders and Torsten also for giving such a great presentation. If you did submit a question and we didn't have time, please know that the folks at Electric Cloud will be getting a copy of all the questions, so I'm sure they'll be more than happy to follow up with you offline. Again, thank you everybody for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you.